This is the Journey to IPv6 Campus of the Future. So we got three speakers. Loghs Srinivasan is an engineering director in Cisco's Enterprise Networking Group, focused in the enterprise space, and have done some pretty interesting stuff in his space. He's got a network as a sensor, network as an enforcer, easy quads, DNA campus fabric, and most recently some very cool IPv6 only solution stuff. Also in the solution space is Mei Fan, who will be co-presenting as a senior manager in the Cisco Enterprise Customer Solution Group, also primarily focused in the enterprise space, done quite a bit of stuff in the verticals, finance, healthcare, and the technology sector. Mei and I both have been at Cisco 17 years. I've worked with her in a previous life, and she's had a bunch of roles, software development, white box testing, and again, primarily in the solution validation, testing, and design area, and we spent some time together in the Enterprise WAN and Campus area. And then Travis is our third speaker, is in the as a manager in the Cisco Global Infrastructure Services team, and he's one of those lucky folks that gets to work on things that are way before their prime. So he's in the early technology evaluation team, and so they're about building and testing things that aren't quite business as usual or ready to be labeled as prime technology areas. Travis works as a lead engineer, or has worked as a lead engineer in that same team, focused on Cisco data center and campus and access network architecture. And he's worked quite a bit on Cisco switching platforms using IPv6, virtualization, and convergence. And so we'll let these guys get rolling.
All right. Hello. Check. Okay. Are you able to hear me okay? Yep. Okay. Okay, my name is Loghs Srinivasan. We just want to quickly go over the IPv6 journey which we had. You might have actually read some of this online. What we did was we transitioned one of the buildings in Cisco to a pure V6 only network, and we jointly did it together with engineering. I mean, we are from engineering, and we did it together with IT. That way we can showcase to the entire world as like how to migrate a campus into V6. That's the journey which we had, right? So I'm going to go over briefly. I think for this forum, why IPv6 matters, I don't think I have to go deep into it. I'll skim through it. We will go through why IPv6 matters for enterprise, particularly why does it matter for Cisco, and what are the reasons why we picked San Jose Building 23 as the building for us to experiment this, or like kind of like get the first building out in V6 only. And Travis and Mei will go over the journey, as well as like what were the challenges that has been faced, and what are the things we had to deal with for making sure like this IPv6 only island or building 23, because the entire Cisco campus is not purely V6 yet. We have kind of migrated one building into V6, and what does it mean to the larger ecosystem and the larger network at Cisco. And the next steps of what we think will be the next steps we want to go forward with as next steps in the larger enterprise community. Why IPv6 matters? IPv6 exhaustion, we do have that in place. We also want to make sure like we have dual stack. We want to just like come out of V4 completely. And one stack, if you look at from the networking background, if you look at a dual stack, every QoS processing that needs to be done has like dual, it actually doubles up. So if you go into one single stack, that is actually really good for the networking products as such. And of course, with 50 billion connections in 2020, we need to have a way to have IPv6 addresses or addresses for every individual IoT device. And that's also the reason why we want to go purely into V6. Right? From the enterprise standpoint, there are two key aspects. One is like some of the customers are also here. Some of the large customers who had come to Cisco and told us like, how do we migrate into a V6 only network? Show us the way. And it's also important as such, because if you look at the web scale companies, the data center is already V6 in many of the cases, and they also want to make sure campus is also V6. Right? From Cisco point of view, I talked about it pretty much. One is like we wanted to make sure from the Cisco IT, we have a single protocol which is kind of going across the data center and the campus. We also want to reduce the overhead for our networking gear. When IoT and enterprise are coming together, IPv6 becomes key. And last but not the least, we want to be the leaders as how we want to showcase to the larger network, larger community as how we want to transition into IPv6. Right? Where we were, this was not an easier journey at all. When we started it around, I have to say, if I remember it right, yeah, August of 2016 is when we actually started it. But the overall journey for the V6 started around early 2016, when we found that like a good amount of enterprises, including Cisco, was purely, it was dual stack. And many of the internal validation which was happening for the networking products as such had V4 first, and we would try to do V6 next. And there was always a catch-up game between the two, right? And also when you look at the network devices and the policy management, we're all done using V4. And if you look at the pockets, wireless was testing V4 separately or developing V4 separately, V4 and V6 separately. And switching was doing V6 only testing separately, and routing was doing it separately. But when you look at an enterprise network as such, all of them have to come in together and work together. So, and that's what we call as solution testing, and that's one of my primary charters as well. We wanted to see how that can be V6 only, right? So where we are now, a few customers or enterprises are moving into a V6 network. We are working closely with larger enterprise customers. I see customers. I should actually say enterprise organizations, because I call everyone who is talking to Cisco as our customers, and that's what I do from engineering, right? And when we also looked at it, we had to make sure like all the facets of testing, right from dev testing to feature testing, system testing, and solution testing, we needed to make sure we have a thorough coverage across the board on V6. Customer solution testing, and that's what I actually call it as. We had to do it specifically for some of the customers who were the early adopters of V6. We had to do specific testing for them, and now we have transitioned that into a V6 only enterprise solution validation. In this transition, what was very, very key is like we were able to get our good partner, which was Cisco IT, and this helped us create something called Customer Zero. I call Cisco IT also as our customer, and that's why we coined a name called Customer Zero, where we had created buildings, building 23, 24, 18, quite a bit of buildings. If you had been into Cisco, there are two different SSIDs. One is Blizzard and one is Alpha. Alpha is a network which is used internally for making sure the Cisco's products and solutions can be deployed at to be hardened in a realistic network. And Blizzard is a corporate network, right? And we collaborate with IT to make sure that like any of the products is being vetted out there. And more importantly, now what we did was we took building 23 and then transitioned that into a V6 only network, right? Sorry, I had been talking a lot about many of the text messages out there or text in the slides. I'll go through some of the solution validation portfolio we have here. This is a Cisco IPv6 solution testing. I had been talking about doing things in a network level. I hope this actually shows. Okay, I'll show this. If you look at it, this is actually the WAN. The WAN part of it, which we had to make sure like it's purely V6. And this is the campus, and this is the access side of the campus, where we have the 3850, 4500, and the different types of switching portfolio, which is being validated. And this is the wireless side. Obviously there's also wireless below the switching portfolio. This is like wired, and this is wireless. and they are all connected to a core, and this layer is a distribution. This is the core, the 6 case, and that's the data center. So if you look at it, it was very, very critical for us to make sure before we go and say that like we are deploying an entire network into V6 only, we had to do it in a Cisco reference network architecture. That's what we call it as. And we had to do a V6 only validation in the Cisco reference network architecture. Platforms which are deployed in the V6 island are in building 23. As I said, as you had seen, like this is the switching side, the access switching. This is the distribution, and sometimes it can be used as an access switch as well. 6800, that's the core, that's the WAN, and the WLC, and the APs, that's the wireless side of the world. So we had to make sure the entire enterprise portfolio is being covered. And these are the different devices which are deployed in building 23. So we came up with like 5 steps forward to do the transition. First thing is like we have to ascertain the goals of the project. It's important to have some key goals. For us, it was super simple. We had to showcase to our customers and also for the larger industry, how do we migrate campus into V6? We passed the long history. In a dual stack, typically like IPv6 transition had been only migration to dual stack. It is important to come out of it and then migrate into a V6 only network. Cisco on Cisco, I talked about this. We actually have a partnership with Cisco, Cisco IT, and we call it the Customer Zero Network, and that's what we use to deploy. When I say Customer Zero is actually a combination wherein like the entire building infrastructure, both the alpha network as well as the Blizzard or the corporate network is completely migrated into validating the products and the solutions. Right. So we work together with IT in this entire project as such, and identifying the ideal project size. If you were to look at it, we couldn't do multiple buildings. We had to pick building 23 as such because it had a reasonable. It had a reasonable capacity. We had about 500 engineers in that entire building. We have 2 to 2.5 on an average devices per engineer, and if you look at the size of the AP also, there are like 120 APs. There are about 20 switches. It was a reasonably manageable one and an island which can be transitioned. Right? Manage early adopter anxiety. This is one of the key steps we had to take care as well, because when you look at the end users, it's not just like a simple migration from V4 to V6. Even accessing the lab, it was quite different because engineers are used to doing telnet and SSH, and they had to have a different way. We had to do like SSH into a domain name instead of direct IPv4 addresses. These are simple transitions, but we had to handle each one of them on a case-by-case basis. I gave a very raw text of like what we did in the entire transition. Now Mei and Travis will go through the details of how the entire transition happened. Right. Thank you.
Good afternoon, I'm Mei. I worked in Loghs organization. I have 2 roles in the organization. One is the solution validation, another is managing the network in the building. The reason I explain this is you can link how the solution validation in a contained test lab to a deployment level realization. So as Loghs said, building 23 is one of the customer zero building. In Cisco, we always have Cisco on Cisco story to deploy the new features and new solutions and new platform, new products before reaching to customer. So we have this alpha strategy for long, but customer zero strategy is alpha team and ETE team actually managing the building. So those building it's not the normal Cisco IT managed building. We have the flexibility to deploy the new stuff before going to any of your network. But on the other side, we still follow the IT practice discipline because it's a live building with hundreds of users. And Building 23 is one of the building. And Loghs and I worked in that building, so we managing the user experience by ourselves. I will explain how it is feel. So during this transition, we take the phased approach. I will go through that step by step. Why do we do that? And during this, we look at the user base. What are the job functions? What are the applications they use? And what are the system and so on? That's just from the directory level. We also analyze the traffic pattern and going out of the gateway so that we are sure what are the applications we need to take care. That's the preparation work. So through the journey, we have multiple workshops to take the users in a room like this to help them to connect to V6. In case they cannot, then we on the site to upgrade their OS applications and so on to transition our users as long as transitioning our network. So that's the multiple workshop. Then during and after the transition, I host the war room in the building. So I have my engineer and the IT engineers to sit there, so to help users on time, to help them to uncover and overcome any difficulty of connecting to IPv6. That's the overall. So this is the poster my engineer designed. If you come into Building 23, each gate of that building have this poster. So it's kind of famous in Cisco now. Now let's go through the phased approach, why I'm doing that, right? So, and when we look at the project size, it's a working building in Cisco. It's 3 floors. It has 500 users, around daily users, and each of them have 2 to 3 devices. So we first decided we will go to enable the client on V6 only. Because in Cisco's IT standard, all the wireless controller WLAN configuration is dualstack as of today as a template. So I know if a device connecting to that dualstack network, if a device has enabled V6 capable, it should take the V6 path. However, for each device, I'm not sure if it's happening. The first thing we did is we turned off the V4 address on that SSID. So I know any client to connect to that SSID is taking the V6 path only. We did this, call it out Alpha V6. I'm using that within our own team, our own folks to test it before it's announced into the larger crowd. So the first week is we did client to internet end-to-end V6 connectivity well. Then we enable NAT64, DNS64 so that any V6 only client can connect to V4 site in case it doesn't have the V6 capability there. So we also enable Slack on our layer 3 gateway. Just because of Cisco IT has policy, we cannot just publish that because we want to maintain the state for DHCP V6 management. So that Travis has been working on through that. So as of this first milestone met, we know our network is in alpha level is working fine. So we have the we did an announcement on that day. I think we had a party basically, invite 100 users and to make sure they all connect to V6, can do their daily work. Those users are from different functional group. So I will have a next slide to say why we invite them, right? So engineers, managers, program managers, release managers, and different functional group, we make sure their application works fine. So after reaching that milestone, we have some period of testing with those users. So we turned off the V4 address from all the data paths. So then in that case, we know our network is ready. The reason when we say from alpha V6 to alpha is the user base. In general, if you go to Cisco, any building, alpha SSID connected to around 200 users because those are the early technology adopters, they always connect here because our Alpha team deploy the latest and greatest software and hardware in Alpha. But it's still a testing phase for any of the product and the solution. So on December 15th, we made the Alpha to be V6 only, and we made another announcement. At that moment, we know we are ready. We are ready as a network provider. So now the next step is to move every user. Just because of the holiday and the Cisco year-end shutdown, we wait until the next January to move Blizzard. So you see the transition from Alpha V6, Alpha, Blizzard, that's the whole transition now. On that day, the entire building 23, the Blizzard users are all on V6 only. And then I will go through what happened after. So just give you an idea, I think most of you guys are very good, are very expert in terms of the network deployment. Here I want to give you some sense of how big is the scope, right? So that's a real building 23 in Cisco. I didn't take this picture, I just Googled it. It's lots of building 23 picture there. So we have 500 users composed from normal engineering, development, and testing, program managers, and the different function, and also roaming users from other buildings to 23. And that building has 3 floors. That's the real picture. We have 66 wiring clouds, and there are overall we have about 500. I think it's 500 to 700 switch port connecting wired users and APs, and we have 120 APs. The 40 plus applications are the network and the user services. I'm going to have an overview of what are the applications running in this network, right? So as Loghs said, we took about 3 months to take the phased approach. Then after that, IT can use that as a template or example if we want to do more buildings. Okay, I just want any of you are very interested in the real network stuff. Here is the building network topology. It's very simple, optimized, and Cisco IT recommend network topology for any campus building. I just did some negotiating with Travis to put some of my interested platform accessing switching platform there because Loghs team is responsible for the switching solution testing for this too. So usually they will put 4K at one as access as a whole. Then I said do something different flavor, and of course I assure the validation before going to the network. So those are the real platform used in case you want to do a template like this. You can just take this and make it happen in any of your buildings. Okay. So the last thing I want to talk about is when we have this project or initiative, right? And when Loghs said we need to do this, I said, Loghs, transition enterprise is 20% of the work is transition the network, 80% is transition the user, because I don't know how many applications and services they are using and what are the settings in their system. Because now somebody will run Fusions in Mac, and their remote system are on VMs and so on. So there are just too many variations. So we need to analyze sense. That's one thing. Loghs and I look at all the directories in the building. There are different functions, as I mentioned. And we did building traffic analysis. We identified the top applications here. That's almost daily used, very heavy. So we need to make sure those are working fine. If we don't have a V6 only solution, then we need to have some workaround, like taking the translation and so on. So those are the ones. Then during and after the transition, we have this identified the focus group. I personally invite them from my friends and friends say, try out if you can do your daily work there. So we have that done. And we have several dry runs and war rooms to make sure user experience is taken care of. So the key of this activity is I don't want anybody just blindly say V6 doesn't work for them. So if it doesn't work, let's look at, right? I personally have to upgrade a lot of engineer or managerial people's laptop in that building. Then I will tell them what's the Outlook version to support V6. And there are some questions I couldn't answer. Then there is we have an alias at the end to answer all the questions, right? So we found not every application is supported V6 only at this moment from the handset and from the system-wise. But most of from work point of view, I think we made sure every folks can work in that building. So those are the ones I'm talking about. Around the 40 applications in service, network service, user service, and applications. So I have the detailed status of how each of them in terms of V6 readiness. And as of now, we created the 23 V6 network is an island, as Loghs mentioned, right? Then how does this island connect to the Cisco internet and internet? The next I will hand over to Travis, and he will go over the external connectivity for Building 23. Travis.
Thanks, Mei. My microphone working here? All right. Hello, all. Here we go. So I'm from the IT side of the house. I'm basically going to tell you the same story that you've already heard from my engineering partners, but from IT's perspective. So kind of before I get into it, I want to set the stage that I think one of the things that's been most valuable to us at Cisco has been this partnership, right? Where this really started is we have long been dual stacked in Cisco IT. Most of our network designs have incorporated IPv6 under dual stacked. A lot of our primary application teams have worked on them. And then I think there's probably been a little bit of stagnation after that, right? We prepared the foundation and we waited for the waves to come. And Mei and Loghs came to me and my team one day and said, it's not that easy, right? They've got customers in the field who are trying to do IPv6 only, and it's not an easy problem. Is it something that we'd be willing to partner with them on and see if we can forge a path through this? And so that one made us in IT step back and think, well, what are the real obstacles here? If our customers are feeling pain, that's pain we should be feeling too. And this slotted very well into a phrase that you've seen a couple times here, is this Cisco on Cisco ideal. It's this idea that within Cisco, we're both product suppliers and manufacturers and users, an IT team. We want to use our own products, burn through the challenges, use them before we ask anyone else to do that. And so doing that with IPv6, it might have been one small step, and a lot of the technologies I'm going to talk about you've already heard, and I'm certainly going to echo some of the things today. But it's for us a big leap forward in readiness, understanding, given what we've done, what is it that next needs to be done to move IPv6 forward at Cisco. So here's kind of my down and dirty illustration of that, right? Our foundations are healthy. We've got dual stacked in almost all of our environments. There's some holdouts here and there, but primarily dual stacked everywhere. Major applications, Cisco.com was launched on IPv6 under IPv6 World Day. We've continued to target specific high-profile applications in IT for either dual stacked or V6 validation. Given all of that background, what's preventing IPv6 in a campus enterprise environment? What makes IPv6 only a challenge was our question, right? Cisco on Cisco, like I said, this is, we thought, a great way to solve this problem. Given all of that background that we had, the fact that there was still this concern and that this was still a challenge, this is ripe for an implementation of Cisco on Cisco. Get a partnership between engineering and IT together. People are on the same page. It's a great opportunity to have that shared goal where it's not IT that is going back and mandating a supplier or a product manufacturer that says we need this, or vice versa. It's two equal partners both aiming for the same goal, and that makes a huge difference. To get there, we looked at In IT, we're naturally risk adverse. You know, we've got fleet budgets, we've got cycles by which we can roll through hardware. We didn't want to go and use everything that had just come off from engineering in their product build lines and build a brand new IPv6 building. We had a heritage we had to follow, and we needed a plan that eventually would allow us to take this one building and roll it to the other several dozen buildings in San Jose, and eventually allow us to roll it globally. And then we worked closely with Mei and Loghs, who had great relationships with our customers in the field, and say, how are our customers trying to build enterprise campuses on IPv6? That's an important data point. And as Mei said, we wanted to be a little bit platform forward-leaning. I'll be honest, Cisco IT, we like to validate everything. We go through a long validation cycle. We like to lower our risk, lower the number of trouble tickets, keep our customers happy. But as Mei said, she encouraged us to take a little bit of risk and be very forward-leaning on a couple platform choices. And you saw a detailed topology a little bit ago, but here's a simplified version. So this is probably pretty universal, but for us, a building is an organizational unit in our network. We've got a pair of Catalyst 6Ks in a VSS multi-chassis that sits on top of that building and does aggregation for that building. Primarily, we use multi-chassis line card 4Ks, Catalyst 4Ks in our IDFs, or our floor distributor rooms. We've got two models here just to represent our variety. Depending on the size of a floor, we may have different sizes. And then we have one floor that we allocated to our individual single chassis model, the 3850, which is, as Mei said, is an up-and-coming line and something that it's inevitable that at some point our IT standard will move there, but it's not quite there today, so this pushes our design forward into the next generation of platform on a single floor. And the principles we followed here are, one, keep it simple. We knew that there were going to be a lot of application and IPv6 specific problems. There was no reason to push the bar on general network design here, right? That wasn't the goal of this. So it's a layer 2 building. At those building gateways is our layer 3 edge. Our routing, we use the same protocols. Of course, it's all native v6 here, so in our case, it's EIGRP. DHCP v6 is the IT standard, so we wanted to replicate that. DHCP on v4, DHCP on v6, full stateful. VSS we stuck with, and then this was primarily wireless. As Mei called out, traditionally we have a lot of networks in a building at Cisco. There's two primary wireless networks where 80 to 90% of our users are wireless today. There's an Alpha SSID and one called Blizzard, which is our production. Alpha is run exclusively by my team with partnerships like Mei and Loghs, and those networks are specifically built to do these Cisco on Cisco stories, or some people call them dog food testing. And so we're working with engineering to take early release products, put them into our designs, and get essentially volunteer users on them. And then we have the production network that supports our business. The ask here was to take both of those and do IPv6 on all of it. We did leave some of our vestigial networks, hardwired printers, hardwired badge readers, security scanners, all of that stuff that brought in a lot of complexity and was actually low volume on the network. That stayed generally hardwired on separate VLANs, separate infrastructure. So that was not touched under this scope. As you can see here is a sample of one of our VLANs in the building for our wireless data. It's all pretty straightforward stuff, managed config, DHCP, EIGRP. There's one exception for Slack. My InfoSec department asked me not to support Slack. We honestly don't like it. It doesn't engage well with our identity tracking and security protocols. But the major exception is Android. It's a platform out there that a lot of people bring to the office and expect support on, and there's no DHCP v6 support on it. Internally in Cisco, we've had some conversations with Google to try and win them over to our side, but as far as I'm aware, there hasn't been a lot of progress on that. So we are working towards an exception about how to better accommodate those users on our network. It's a fight we're probably not going to win. So where this all kinds of ends up as soon as you build it is, despite the dual stacked, a internal services, a lot of them either don't have IPv6 at all, or they don't support it as good as you'd like. Certainly some of the stories we heard from Stefan. What you end up with pretty soon when you go v6 only is you end up with this island, right? And an island sounds nice. Who doesn't want to be on an island? But it's far from what you might hope it to be. So DNS 6.4, NAT 6.4 really becomes a critical enterprise service in this environment, right? Before this island, that was not part of our IT standard. We didn't have a tier 1 implementation of DNS or NAT 6.4 on our networks. So this has already been walked through a little bit, but I'll summarize it again. I think the important part is we've now got these hosts that have v6 only. In our scenario, we don't have 646 LAT. We don't have anything that supports v4. And so clients have a single interface on v6. We've got the DNS 6.4 server, which for us is a recursive DNS 6.4 server on bind. That's somewhat of an artifact of our initial build. Eventually, this will be integrated into our existing DNS infrastructure. But right now, it is a standalone server that supports our campus edge. And this makes it look to that client like every lookup it does, every service it wants is actually available on v6, whether it is or not. Some are native v6 records. Some are synthesized v6 through the NAT. And then at the edge of our campus network is the NAT 6.4 servers, which translate for those synthetic records that might be. Native v6 traffic, of course, bypasses the NAT server and goes directly to the server host. Netted traffic goes through this. Originally, we did our first deployments on CSR, virtual routers, in our data centers, and they worked very well and proved out our proof of concept. But for scale and efficiency reasons, in terms of traffic path and a number of hops, we moved those into a pair of ASR 1000 routers on the edge of our campus core. One thing we really liked about this platform is it's a very simple config on ASRs to get a pair of HA resilient ASR platforms running stateful NAT 6.4 overloaded to a v4 pool. 4 basic lines of config shown here. There's a little bit more to, of course, get your interfaces running and HA between the two chassis. But honestly, it's a pretty straightforward config. And we found it to be highly stable and very reliable. DNS 6.4 carries the majority of our traffic today, right? So despite the dual stack, despite some of our keystone applications being validated on IPv6, 95% of our traffic is going through NAT 6.4, DNS 6.4 services. So that's a highlight that it's business critical. That said, we heard, I think, some great examples from Stefan here today. It's not magic. There's just a lot of things, even though it seems like it. We have a building that you flip a switch on, and people come in from 1 week, 2 weeks off on Christmas break, and suddenly v4 is gone. That building is v6 only. Almost everything works. If you turn off DNS 6.4, almost nothing works, right? So it does seem like it's a magic bullet here, but there are clearly these outliers. Load balancers and the DNS error codes that you heard a little about earlier. That's a big one. This certainly gets exposed, is that applications that go through load balancers, sometimes there's unpredictability. We had an instance in our case where our internal WebEx services are primarily hosted out of Mountain View with a failover to a Texas data center. The Mountain View implementation is fully dual stacked. The Texas data center is not. It's v4 only. We expected it to work fine even on failover. NAT 6.4 works fine for WebEx services. However, the DNS load balancing, when it failed over, we had exactly one of those DNS failure scenarios with the DNS servers interacting with the load balancer when running out of Texas, resulted in a server fail code to the client, and DNS and WebEx was unavailable internally when this failover happened. So for us, despite the rule that you may have heard earlier, we did do some manual overwrites to make these things work for us in our environment. At the same time as we're applying pressure to these application teams that IPv6, it's past best practices. We have customers, hundreds of them daily, on this and you need to fix it. So we have the internal pressure to identify these outliers, find the people who are not playing well, and get the pressure to get progress on those. Partial IPv6 implementations as well. Plenty of internal apps built by teams and services that advertise v6 services in DNS, but don't actually support it, don't respond to the TCP on transactions, or the web server isn't actually offering the same content over v6. So that has all been kind of the summary of what we've done technically to make this work. Very successful, but I think one thing that we maybe underestimated in the beginning and has been very clear from IT is it's not all about the technology. If you go into an enterprise and you take a building of 500 users and 2 to 3 devices each, you want to make that seamless for a user, but it's not going to happen with IPv6. There's a lot of culture and there's a lot of process change that actually has to be done. And managing that through some of the things Mei talked about understanding use cases. We have some users who are really heavy technical that are doing a lot of work with VNC and remote access and scripting. And we have other business users who are spending a lot of time in email and WebEx. Understanding these user classes and validating them is important. And especially for us on the engineering side, there's a lot of people who are familiar with IPv4 literals. We've got a lot of technical people in Cisco. Not all of them are network engineers, but they're still very comfortable with IPv4. And so literal IPv4 use is very common, especially in our labs and other engineering spaces. And working with those teams to, one, provide a bridge to go over to name-based access. This is something we really focused on educating our user bases. Stop remembering numbers. Don't even try with 128 bits. Move to names, right? It's the next way that services are going to be accessible. IPv6 and for other reasons is name-based access. And so that's a message we continually talked to our users about in these working sessions and in kind of community events that we would sponsor in the building, is encouraging people to get used to working with names, make it easy for names to work for them. So we went through labs, and we have blocks of sandbox labs that are all internally scoped and that don't have a host name. Give them a numeric host name that goes with it. So anybody can automatically say, I don't know my host name. You do know your host name. Dashes instead of dots. And then eventually we made that self-service. We set up a chat bot. People can go on and say, I need this subnet or this host. I need automatic DNS created. And automatically, the system will go in and create dash names for them. We could, of course, went through Cisco's entire lab space and bulk created these kind of names, but this was a single building, and we really didn't want to kind of blast such large scopes automatically, but it certainly could have been done. We like this kind of self-service model to hit the hot spots. I think the number one lesson is enterprises are complex. As I said here, DNS 6.4 doesn't solve it all. We had problems in hard-coded IPv4s. Multicast also was an issue. Multicast design over v6 and v4 has some interesting differences. We've got a lot of engineering teams who have built scripts over the years that run their infrastructure or are important to their productivity. Those often are places where IPv4 literals are hiding away. And then various discovery services. Some auto pairing that we have called Cisco Proximity and other non-IP protocols. A lot of them have literals baked in. And then the client side. As Mei said, we spent a lot of time working with clients. Upgrade your apps, building together a list of the common apps that our different use cases use, local virtualization, conferencing, email, VNC clients, which ones support IPv6, which ones don't, which ones require names, which ones might support bracketed forms of IPv6 address notation. That kind of matrix of client-side application support is critical to provide to people. Otherwise, you're just going to be repeating yourself a lot and a lot. And ultimately, IT operations is a client too. I think this is the number one holdout that prevented us from doing this before, is that managing and operating a network is like being a client. There's a lot of expectations you have out of your network. There's a lot of things you need out of it in terms of how you access it, how you get your instrumentation and telemetry out of it, and how you integrate it into so many of the other IT pipelines that we have today. Especially at Cisco, we've got a huge tapestry of systems from InfoSec to IT to business operations that interact with our infrastructure. And IPv6 only means moving all of that too, right? Moving all of our CapWAP between our centralized wireless on the IPv6, admin access and SSH and Telnet, moving SNMP, NetFlow, syslog, all of our protocols, moving that to IPv6. There's a lot of complexity in there, especially when you're dealing with that huge environment of applications that have to consume that and report it, and trying to get it to, it's not a direct translation in some cases. It's easy enough to take SNMP and encapsulate it over IPv6 over IPv4, but that's not the same thing as now that I have an IPv6 interface. Are my counters the same? Are the fields in the byte sizes the same? How much of that changes? There's a lot of detail in there. And ultimately, I think what we learned is that this is why the journey mattered. As I said, in the beginning, IT had sat down and done IPv6 versions of design. We had pushed out IPv6. We felt like that was getting over the hump. But the reality is doing it in the real world matters. You know, getting out there, having the right partners, and putting this in front of users exposes all of the holes that are so time intensive to cover through design and lab validation, right? And so crafting an environment where you can segment off your risk, you can validate this out and with customers that are willing to take on a little bit more overhead and maybe a little bit of higher level of service tickets, proving it out there really provides a valid, trusted template to grow this across a campus or a global scope. Real data is how you sell it, right? Looking at the data of the amount of traffic we have, what is going where, the fact that I can go back to our major internal apps and say, this is how much our business and our internal users rely on our Exchange service, our Active Directory, our WebEx services, and say, you don't natively support IPv6. That's a huge problem, right? We've got numbers to make that argument now. And ultimately, you've got a real incentive when I can say, I've got 500 users in this building who can't access WebEx, which runs our business when you fail over to Texas. That's something where you can easily get that service owner on your team to say, yeah, that's important to me. I don't want to disenfranchise these users. I'm on board for taking your offer and helping to get IPv6 running. So after we've done this, what are the next steps we've talked about, right? So a lot of it is documenting this, building some templates, and enabling growth, right? This was like I said, a big leap for IT in getting a building that functions this way and having the right partnership to get it done. Now, how do we scale it out with less overhead and quicker? And that's building templates and building a standard around this. We're also pursuing very actively migrations in our data center. It's a little outside the scope of this topic, but as I'm sure we're all aware, with containerization, IPv6 is a must in data centers, and certainly for Cisco. So that, for us, is a great parallel track, that as we move our users and our access edge to IPv6, IPv6 is going to be exploding in our data center over the next year. As Loghs mentioned, Cisco validated designs, taking these documents that we're doing not only internally, but working with our engineering partners to get them out to our customers, and into the hands of our engineering partners and TME teams is where the real value is at, right? It's one of the reasons we embarked on this. Loghs spoke a lot about the development process. Actually getting full equal parity between IPv6 on every new product as it comes out is a huge effort for us and something we very much are pushing at. And then continuing to work with the industry to drive this. As I said, there's still a bunch of outliers, right? There's our suppliers for printers and security systems and IoT systems, and getting all of that IPv6 ready. That's a place that Cisco IT and especially our engineering partners want to really play a role and continue to push that. All right, that's the end. Questions for the three of us, and we also brought some actual engineers who can answer real questions if you have them.
So I have a question in regards to whether this was an in-place configuration that you shifted over to, so you stripped V4 off the systems, or was it actually something you stood up as a net new V6? And the reason I ask is when you're first deploying Cisco handsets and you're trying to TFTP boot them and you don't have the capability to do that in V6, how are you exactly getting firmware loaded? How are you getting registered with communication manager, et cetera? So I'm sort of curious just how far along you actually went. Was this a raw, full build versus something in V4 and we took V4 off and therefore it was still registered and still could do the discovery that was required?
So it was a raw V6 build. I mean, the configurations on the back end were built up from dual stacked with V4 stripped off, but the live environment was not stood up dual stacked and then converted to V6. It was freshly built. The collab piece you call out is something that we didn't really discuss here, and it's a good call out because at the time we did this building, a lot of our collab suite was not at parity. So problems like you illustrate were not there. We're actually just this week doing testing on the alpha program, some new releases that address a lot of that. But collab was a call out, and a lot of that infrastructure remained on the wired side anyway, so it wasn't part of our purview for this.
Hi. There's a lot of security products, especially host-based security, that claim full V6 support. Implementation, did you have to run dual stack? What were some of the problems you ran into?
What's an example of host-based security? So I follow exactly what you're...
The whitelisting systems, the additional anti-malware products.
802.1x supplicants.
Yeah, that too. That's an issue.
Yeah, so I mean, if you're referring to kind of things that we may run on our corporate edge or our firewall, because of dual stacked, a lot of those policies were in place. Honestly, we didn't really have a problem with that, moving more traffic over to IPv6. And as I said, some of that may be masked today because we have this NAT6 floor layer, and by the time most of that traffic is hitting our edge security appliances, it's V4 anyway, right, if it's egressing Cisco. .1x supplicants, that is another good call out. It's another internal next step for us, as we actually have pushed .1x supplicants as Cisco-wide policy everywhere, wired and wireless. We currently don't have it on IPv6 because of it's another area where some of our platforms are still a little behind. But it is top priority for us that we've identified that there needs to be V6 parity for things like that on our platforms.
I just want to add on what Travis said, right? The TrustSec and the role-based policy and so on, those are the new features and solutions. As we said, from now on, any new features and solution, we will have a V6 roadmap. For those ones, and the availability in V6 is in probably, for some of them, we know what exactly date, like this role-based policy and the security features. I can tell you it's in November probably for the TrustSec, right? And for others, and we have to look at one by one, right? And also I want to just double click on the boot up a new system in a V6 environment. That's not what only this transition need, and each customer are asking for that. If I have a box come in, can I just boot up it from run-mount V6 only, right? Now, I think the Cisco product, the procedure is every box you got an image in the boot flash, so you will boot up it. The only thing, we also know some limitations, like V6 support on the run-mount is not there for lots of platforms. So those are the ones we can easily deal with here because ourself is a V6 validation, a solution validation, and in this case. So, but That's also the learnings. We know those are the places we still need to do more work.
So from your presentation, I wasn't sure if you're supporting Android phone or if they're on a separate IPv4 network still. Because we face the same story here with our InfoSec, and basically we look at it, and the solution which is preconized is a pool. So you're logging to the router switch controller, and then you issue a command and then grab that and then save it. So you have got the MAC address and the IPv4. What could be interesting is to have a push. So every change to the neighboring table is pushed to syslog. So like this, as soon as the device comes on it and you get the MAC address, you get the IPv6 address, that takes care with privacy address, that takes care with everything, and then you push it to syslog, where our InfoSec people will be happy to do all their forensics and retrospective on that. So I'm not sure how you are addressing the problem of Android device, because that's only Slack.
Yeah, so today for Android devices, it's a separate dedicated SSID that is for use for Android only, because we don't want to enable Slack on any of our other mobile platforms, laptops or iOS. In that, you've kind of hit exactly on why Slack is a problem for us and enterprises in general. What we're looking at right now are radius accounting features in our wireless platforms to do much more of a real-time push type. This is syslogging or radius accounting messages that will update neighbor changes.
Yeah. I think one thing, I don't know, as a feature request, one thing would be nice is to get the neighboring table change to syslog without having to go in debug mode.
Okay.
Yeah, I think we are the engineering team. We'll bring it back to the engineering team. So we'll actually take it in.
Please.
Thanks.
I want to echo everything he said. I'm glad he went before me.
All right.
What is the literal challenge you're planning to solve as far as like the IPv4 literals, right? So if you're going to like take IPv6 only to the whole enterprise, right? You have a lot of people who are using just hard-coded IPs. What's the idea of maybe delegating that out besides a chat ops style thing to like give people the power to actually be able to like make their own DNS names or some sort of way of doing that?
Well, yeah, so by and large for us, in the holdouts are in IT managed environments, naming is already well managed. So I mean, if you're deploying production services under IT managed environments, naming is done from day one and really hasn't been a problem for us. But in self-managed engineering labs and in other more loosely managed environments, that's where naming doesn't happen as a rule, or it is left up to the individual. Most of the environments, users probably have permissions inside Cisco to provision their own names if they choose to. Honestly, they often don't. So that's where we're trying to make that more visible and easier to people through tools like ChatOps or self-provisioning of names. Does that answer your question?
Yeah, it does. Thank you.
Yeah, so
Yeah, I want to
on
just
top of
add
it,
on.
we also had to do a lot of communication before we did this transition, because the reason why we went into multiple phases, Mei actually mentioned we had an alpha V6 only SSID. That was more like initially a test only SSID. So we had to tell the entire team, entire building user, saying that this day we are planning to do the transition. Just make sure all your applications are working, right? And the first thing that will come in is like, I just connected it. Outlook doesn't work. So we had to say that, okay, you have to be in 15.3.6 or some version. So we had to have a war room where they can. We had like IT and engineering team both together sitting in. We had to walk through any of the applications which came in, document it, and also help them transition it. So then we put a transition checklist saying, if you have a problem, then please make sure this is a place where you go for. All your applications, including Jabber, WebEx, all of them had to be one rev up, because if they had been using a version which is not V6 ready, then they will not work. So it was like the transition as such. After that, after they migrate to the later versions, they would, at some point of time, they blindly did it, thinking that okay, it's a later version, let's just go for it. And in some cases, I got one feedback saying like, I don't even know whether I'm in V6 or V4. So certain users, it was like that, and some of them were like, I'm not even able to work, right? The ones we were like still sitting in older Microsoft laptops, they had quite a bit of problems as such. The one in Mac was reasonably okay.
Yeah, one thing I want to mention about the literal of V4, right? If you remember in my slide, there is a focus group called release management. In Building 23, there is a release group. They build the images for not only Building 23 users, they build for every Cisco OS and so on. And before we take this to action, we looked into that, say we absolutely cannot break any of their work because then there's going to be a big deal. Fortunately, as Travis mentioned, any IT managed and production server, they have a name, DNS name since day one. So as soon as DNS 6.4 and Net 6.4 is there, we never have any problem. The main challenge is from the engineers, like my own engineer, they are using 10.0 network and 170 network, telnet to this testbed, that testbed. So to do it, to give them a name one by one, it's impossible. So that's the auto translation Travis come up. Just replace the dot to a dash to make that happen within that 3 months.
Just out of curiosity, you mentioned about card readers and other BMS or building management systems. Is there a plan to go back and change all of the BMS systems over to V6 as well to have a truly V6 only building?
I would say there's a desire to do that. At this point, it's not on the plan for the next year, right? There's a lot of dependencies on those BMS systems, provided by vendors, and there's contracts behind those, and so there's just a lot more complexity there outside this realm of control that we have. But certainly, that's where we want to go. Yeah.
So sort of a follow-up. How much visibility are you guys gaining in terms of like feature and function parity that you guys have within the product line? And for you locally, in terms of running the building itself, the telemetry data that you're getting back about how much V4 versus V6, how you do event correlation, and are you using that to feed back to the product group to say, hey, this is the sort of information we actually need? Sort of want to understand how your guys' loop is working around that. Because it's a big problem today for end users in terms of those that run networks to really understand what's happening there. Obviously, besides the Slack issue, there's a lot of other things that go along with that, obviously on the wireless side too. So I'm sort of curious where your experience has been on that, what you think the progression is.
Sure. So
I can take that first, then Loghs can cover. Right? My own team is V6 solution validation, and we test the switching platform, wireless, and routing. So in terms of feature parity and also the status, we know in document for sure, and we're also going back to check with each team what's the current status. One thing in 23 have another challenge is I also deployed the latest wireless product from Cisco that has to work on V6 only, like a CapWeb over V6. I know exactly which release that feature come in, and that's the feedback given to IT. Then how do we work with the upstream team to get features covered, the scale, performance stuff?
Yeah, so there are two aspects to it. One is like, what do we do about the past? So when we started on the transition, I think I touched upon it briefly. So we had to make sure every phase of testing, even automated scripts, all the way from basic automated scripts all the way till the end-to-end solution validation, we had to make sure it's been done in V6. We had to create a V6 only profile for us to get to a point wherein like we can migrate the products really into V6. That's one thing we had to do a catch-up. The other major thing which we had done together with this entire transition is like we went into a point wherein like at least in the networking side of the products, our SVP, we had convinced our SVP that any product which is going to be, any feature that's going to be put out there in the future releases will have to have a checklist, or sorry, will have to have a V6 parity. If it's not V6 parity, they must have it committed in a subsequent release or a maintenance release for them to be for their feature to go into that release. So does that include Meraki? Not yet. So this is This is on the networking side of enterprise networking group side of platforms, right? So I think we have to take it into the larger Cisco community as well. Right? I mean, we'll have to take that feedback.
Yeah, and to address your telemetry question, very much. I think that's exactly one of the reasons why, from the IT side, we wanted to invest in the time to build a V6 only building with our partners and run it that way. This building is not reverting back. It's not moving to dual stacked. It is staying 6 only, right? So taking that telemetry, and we have a quarterly readout about V6 growth and where we're moving in Cisco IT already, but this data is really hard data to identify where we're going to push that. It is staying V6.
It's staying V6.
Of course.
Yeah. It will not. Yeah.
So in your next steps, you had commented about enabling data centers and containerization. I was just curious if you would elaborate a little further on the scale and the challenges you might see, particularly with virtualization, containerization, and data center V6 enabling.
I wish I could. It's not really my area of expertise. It is, in terms of what we're looking at in the next year at Cisco IT, the campus edge and then IPv6 only enablement in our data centers specifically for our container strategy are the 2 primary focuses. As far as the details there, it's a little outside my purview, so I can't provide you with a lot, sorry.
More to come.
Yep.
Something you said earlier alluded to that you guys just did this to the wireless networks, is that correct?
Yes.
So is there a plan to do this to the wired network? And
yeah, there is.
that forward?
To be honest, 80, depends on the building, but 80 to 90% of our users are wireless exclusively. In fact, moving into the future years, Cisco is moving towards not deploying structured cabling in our cubicle buildings anymore, other than in conference rooms and a few special places. So wireless is the primary and eventually the exclusive access method for us. So that said, eventually in some of our legacy buildings that still offer cubicle patching for users at their desks, those would be migrated to V6 as well. Plans for other systems, security, building management, that type of stuff, it hasn't been committed, as I said, so that may stay hardwired and on legacy dual stacked or V4.
I was more thinking about things like desktop phones and whatnot.
Yeah.
Yep, that'll be moving
Yeah,
wireless.
that will be.
Interesting.
So on the switch port side, every configuration is ready. We also tested the IP phones and so on. Right now, we are waiting for the next generation of CUCM and the CLAB product to offer the V6. And we can get the alpha version to this building. So that part is covering. We already have a date. And the security and the badge readers and the different and probably has, if it's not Cisco product, then we need to work with the industry to get everything into V6.
Yeah, every desk every individual's desk has like two ports at least. One of them goes into the V4. The other one can go into the wiring closet, which we have for the V6 only network. So that can be patched in and we can move it anytime. It is just that we wanted to migrate the wireless world first, then we will incrementally move the wired side of it.
Yeah, I just wanted to say congratulations for doing this. I think the Cisco website was a little bit late to go on IPv6, but getting an office building on IPv6 is helping us a lot because we use a lot of your technology and we don't want to have to fix it. It's better when it comes out of the box and ready. So thank you very much for doing it.
Thank you.
Thank you.
Thank you.
Thank you.